I want to do is to talk you through the eLTER in the next couple of minutes. eLTER is one of the research infrastructures participating in the BioDT project, mainly on the part of data provision, but not only, but also in the data model development and implementation. So the colleagues from UFZ. We have Jana here, we have Ute here, so any questions, so there is some backup with what I'm talking you through. My name is Johannes Peterseil. I'm from the Environment Agency Austria, leading the team on ecosystem research and environmental information. And in the frame of eLTER, in the eLTER project, I'm participating in the information management, work packages and activities, and mainly focusing on the requirements, and that is also why it's quite good to be here, and also to learn a bit more about the use cases and what we have to deliver in the future. eLTER, the eLTER is in the phase similar to DISCO. So eLTER entered the S3 roadmap in 2018 and is now in the preparatory phase with basically two projects supporting this process. There is the eLTER Plus project, which is focusing on the prototyping, piloting the services, and also gaining an insight on the scientific value, and the eLTER PPP project, the preparatory phase project, which is working towards the governance model of the eLTER, which should be operational 25 plus. So what we are aiming. As Jana already mentioned, there is also this VATARA model, and I will come to that. What I'm like to talk you through is basically three parts. There is one on the background of eLTER, what eLTER is about, and order to understand a bit more. Because also the question of sites, Sharif mentioned site in our perspective, it's really an observation location, not a museum, but it's really the place where things are collected. Then a bit about the technical infrastructure we are doing, and the last part, some slides on the relation to BioDT. What we are trying to do. So what is eLTER about? So in order to understand the effects of global change and climate change on ecosystem processes, it's needed to have a quite holistic approach in collecting information simultaneously on ecosystems. So eLTER, the Integrated European Long-Term Ecosystem Critical Zone and Socio-Ecological Research Infrastructure, which is quite a complicated name. So that is why we normally just refer it to eLTER, is a site-based approch. So it's really focusing on catchments or on ecosystem types. So it's with a defined area. It's long-term observation on research, focusing on a whole system approach, and they will come to that in a minute. And the important thing, it's covering a quite broad biogeographic range. So it's really covering Europe in its geographic terms. So starting from Israel to Sweden in the north, and from Portugal to Slovakia in the east. So it's really covering the all biogeographic gradients we have in Europe. It's addressing key drivers of change. So it's focusing on this input and output variables, but also focusing on the change. Just a second, on the change of the ecosystem itself and addressing the major European ecosystems and socio-ecological systems. So that it's not only in natural habitats, but also covering agricultural areas, even urban areas, and it's addressing also this human nature interaction, focusing on the LTSCR platforms. So the main aspect is ecosystem function, biodiversity, and ecosystem services, and that's a quite nice link to what BioDT is going to do. eLTER, the eLTER sites have a long legacy. Most of the sites are originate back to the early 90s, where the forest died back, but there are also some other sites which have a longer history, even before. So we are building on a long time series of data sets with legacy data. So that's a bit similar to what DISCO has, with all its problems of harmonization and also access to the data or the information. And this is also what the eLTER approach what the eLTER tries to approach. So conceptually, the background is the Wales approach, and Ute, I think, will be able to talk more about that, what stands Wales for. It's the whole system approach for in situ research on life supporting systems, so covering on all these elements of an ecosystem, and it's combining with this orange ellipse and this upright. So it's a combination of horizontal and vertical components. The horizontal component stands for the interaction between the environment and the human use of natural resources, and the vertical components indicates the interaction across scales. And for both, there are different concepts we were using, and basically eLTER selected the pressure pulse decay model by Collins for this horizontal component, and this macrosystem ecology for the vertical components. According to the integrated Wales model of eLTER, aims to investigate this human environment interaction at the scale of in situ sites, so that's on catchments or regions, through their nested design, and covering also this continental scale through representative composition in its distribution of the network. So that's the conceptual background we are doing. And when translating this to the array design, so each of the categories is following this whole system approach. So what I said, so it's covering all the different aspects. So from the geosphere to the atmosphere, including the social ecosystem, the social ecological ecosystem. So this human nature interaction, and aiming to provide a set of services to research and to different stakeholders of the research infrastructure. So that's the main element, is this basic site infrastructures, which are sustainable, which have this long history of data, but also providing then services on top of it with data nodes, integrating baseline standard observations, which are really harmonized across these different sites, but also linking to existing other data sources, what we call this information cluster. So really provide this information for scientific research to perform them in future. And it's mainly about this access to sites and data through a central service portfolio. In the long, eLTER aims to build on to about 200 innovation hubs. These are not newly created sites, but it's building on a legacy of about 520 eLTER sites and LTSR platforms in Europe, which are which are there. What are the main scientific questions? So we have now this conceptual design, which is this Wales approach, and the main questions, and that is also a nice link to what BioDT does, are these great challenges the LTRI tries to address, which are also linked to major European policies. And that ranges from biodiversity dynamics and focusing on biodiversity loss and the effects or the reasons for biodiversity loss, to the effects of climate change, but also eutrophication and pollution and its effects on ecosystems, and on this human nature interaction in terms of usage of resources and sustainable management. So there the focus is really on, for example, nature-based solutions or sustainable management. In order to streamline these observations, eLTER is focusing on the definition of standard observations and standard variables. So that's one line of harmonization and integration, and that's a process which is ongoing at the moment, which allows in the future to develop what we would call eLTER standard data products, which are of added value to a greater community of users. How will eLTER be organized? eLTER will have a kind of a head office and topic centers, which are providing also this the central services, which is a service portal which enables the access to the components of the LTRI. But, and that's a very important part, it's also having this site part, so this national infrastructures with the LTSR platforms, which are regions up to 7,000 square kilometers, and eLTER sites, which are normally at catchment scale. And this central service portfolio provides the access point to the users. So the main services to provide will be access to the physical infrastructure on the one side, using research sites for experimentation projects, whatever. But there is also the second part, this access to long-term in situ data, which are, going backwards, using the legacy data, but also in future having a higher standardization through the standard observations. There will be services on data and analysis, on analytical tools, on quality control, so to support data workflows in the research infrastructure. And there will also be a component on the support, training, enhancement, and development of future research technology in the future. So that is what eLTER is providing, and for a number of different stakeholders, where the research community is for sure one of the important ones, providing this access to site and data. But there are also these internal stakeholders on this harmonized workflows for data curation, quality control. But there is also this bigger part, which is from environmental policy decision makers, which are using or should use the results of the LTRI in the future. What are the tools and services we are building up in the So we are similar to TISCO in this preparatory phase. We have this research project ongoing, doing this piloting and prototyping of the different services and building them up in order to enable a fair data flow in the future. There are a number of existing components we have. The important part for the eLTER is the eLTER is a distributed system, so building on the national research infrastructure, which you see on the bottom of the slide, which is the main building block for the observation in the data acquisition and data provision, which are then managed through a number of central services, which can be then accessed through this ARI service portal, which will be this single entry point for the user community of the eLTER. So there are different components which are existing. We already mentioned TIMES-SDR, which is the main registry of sites, so which is this observation context, which enables this linking. We are using also persistent identifiers there with the TIMES ID. There is the component of documentation, the digital asset register, which is the main catalog for the eLTER data products. There is a visualization component with EcoSense and the data integration portal, which enables to visualize data. So there is a prototype available on that. And the main part, there is this data layer, the central data node, which manages data from the eLTER according to different data processing levels, which are from quality control integrated data up, and that's something we develop at the moment to synthesize the eLTER data products, which should integrate data from a wide range of sites. There is a component which is called the eLTER data labs, which allow to develop analytical pipelines and data processing chains. And there, it's also a quite important point what we are doing also in the BioDT project in work package 5. It's on how these workflows also can be documented and described in a fair manner and linked to the data products, which is the part where we are working on provenance and provenance model on how to link this information. In addition, we are also using services from the EOSC context. So namely at the moment it's UDAT services for intermediate data products and data collections. So that's B2Share and B2Drop to have some places to collect information. In terms of semantics, we are developing the EMFTES vocabulary and the eLTER controlled lists, which allows this annotation using an ESCOS vocabulary in the different metadata, but also on the data level. TIMES-SDR is one of the central components in the management of the site network. We have in the eLTER context, it's about the documentation and the description of the physical observation infrastructure. So that's the site on the one side or on one hand, or the LTSCR platforms, but it also goes down to observation locations, to sensors and so on. So that's really this documentation of the physical infrastructure, which then can be linked to the different data sets. What we do through the TIMES ID, which is a persistent identifier to allow unambiguously identification of these components in the network itself. What we are doing now at the moment is this prototyping and combining key elements of this eLTER IT components to provide value to the users. So that goes from the documentation of the sites to this visualization of information and access to data to have a kind of workflow upstream to do that. It's also about mobilization of current observations, so which are ongoing, but also going back in time in mobilization of legacy data, which in terms of eLTER are both biotic and abiotic information, which are collected on the different eLTER sites. So where do we see this link to BioDT at the moment? So I had a quick look on the different use cases, and I think the eLTER can provide information to most of them. Basically, also to the genetically detected biodiversity, which I haven't marked here, because they are especially information on the environment, on abiotic characteristics is important. And so I think this is what eLTER really can provide on the level of the different sites to have this combination of, for example, like deposition, soil characteristics, but also runoff, which is quite important for the different models, but also like on soil physics. What we did, and basically that's I think also similar to what DISCO or other research infrastructures did. We are checking on the capabilities of the eLTER infrastructure. We looked or we had contact to the different contributing sites and looking into what kind of data they are able to provide on which temporal and spatial resolutions for continuous observations or sensor-based observations we have here, from air quality to soil, water, or so to the different components of this life supporting systems, and also to the what we called plot-based observations, which are with a lower frequency, so it's 1 year or every 5 years, where we have information on habitat diversity, soil physics or soil characteristics, or vegetation. So basically, there is this overview. These are just some examples. And what we are doing at the moment is building what we would call a data lake, which is this this access to information, to eLTER legacy data. This is done in the frame of the eLTER Plus project, and this is also where we, for easier access to information, for example, we are using this UDAT B2Drop service as an intermediate data store for data collection and data processing, and also, for example, Time Moore from UFZ is now working with this data. That's not the end. We are also working on the harmonization of information, and that's I think would be the main link to the BioDT project. This is done within the science cases of the eLTER Plus project to create what we call pilot data products. So they are screening the data across the different sites, harmonizing them in terms of spatial temporal resolution, but also in terms of observation. And this will be published through the central services like this eLTER Digital Asset Registry and stored in the eLTER central data node. And that will be, I think, most probably this relevant data sets for BioDT. At the moment, we are envisaging a file-based data provision, which is on this, what we would call this level 2, which are integrated and harmonized data sets across the different sites, which are then accessible through the central services. In the eLTER Plus project, we are working currently on this piloting, and that also will be this main interaction, I think, with the BioDT.